Morning, astronomy kids. This is Mr. Johansson. Today we're going over question 7, which is how did the frost line cause differentiation in the solar system? I think that's what the question is. That's what the question is, frost line. So let's talk about the frost line. So we have this huge cloud of gas and dust collapsing to form the sun. It's radiating its heat away, which lets it collapse. But finally you get to a point where the gravitational collapse is getting so intense that now you have the early sun starting to form. Now gravity is going to take over. And even though as it becomes a thick object, it can't radiate heat so well from the interior, it doesn't matter. Gravity is now pulling everything down onto it. So it heats up. It heats up, it heats up. Finally, the sun turns on. We'll talk about how that process works when we're talking about stars, but the sun finally turns on. What that means is in the solar system, you get closer to that sun, it gets hotter. You get farther, it gets colder. So now we have to start putting some numbers down. Check out what the solar system is made of, okay? It's made of 98% hydrogen and helium. Now, hydrogen and helium really doesn't get together and condense to form planets. 2%. The other 2% is going to be forming the planets, at least initially. So what is that 2%? What is that material made of? Well, of that 2%, 0.2% of the entire solar nebula is metal. 0.4% is rock. Okay, well, what do we know about metal and rock? Well, we know that even at fairly high temperatures, a rock is happy to stay a rock. Metal is the same thing. Very high temperatures, a piece of metal is happy to be a piece of metal. Doesn't melt or vaporize until the temperature gets extremely high. All right? The remaining part is 1.4%, and that is ice. So by far more, the greatest part of that 2% is ice. Now let's see how that plays out in the solar system. Okay? So the sun first turns on. You have a region of space around it called the frost line. Okay, so what's going on with the frost line? Well, that's where the temperature is low enough for ice to form. Inside of that, ice can't form. So what do you have to work with? Rock and metal. That's it. It's not a lot of stuff to work with. But you have 4 planets that were formed basically out of rock and metal. The 4 inner terrestrial planets, right? So you have Mercury, Venus, Earth, Mars, all form inside the frost line out of rock and metal. Now these planets are tiny compared to the outer planets. So let's talk about what happened with the outer planets. Once you get past this line, you have the ability now to form much larger objects because instead of just rock and metal, you still have rock, you still have metal, but now you have a whole lot more stuff, which is ice. So now you can form planetary cores that are going to be considerably larger. And they're going to have metal, rock, and ice inside them. So a number of planetary cores formed outside the frost line. The very first one to form, apparently. Now, this is a prevailing theory. It is very possible that this model of solar system formation, as we learn more about things, will be added to, adjusted, and possibly thrown out altogether. But it's a valid model to at least begin thinking about. So even if it is found wrong, it's a benefit to have a model in your head, so when you see a better model, well, you can make adjustments. This is a pretty good model, all right? The first planet to form was Jupiter. The next rocky icy metallic core to form was Saturn. But Jupiter formed first, and it's a little bit closer in towards the sun, where you have a higher concentration of material, including hydrogen and helium. Now, hydrogen and helium are not going to play in a normal planetary process. They just don't condense into anything. But if you have a rocky core that is really large, like Jupiter's is suspected to be, it can sweep up all or a great deal of the hydrogen and helium. And Jupiter certainly did. It brought in a great deal of the hydrogen and helium. Most of the leftover hydrogen and helium went to the next rocky core to form, which was Saturn. Saturn got less hydrogen and helium. And they had cleared out most of the hydrogen and helium. So when Uranus and Neptune formed, really was not much hydrogen and helium left to condense on them. So why did the gas giants get so big? Because ice was available in the outer solar system that let the core of the planet, the metallic, rocky, icy core of the planet, grow to possibly 10 times the size of Earth, which is the biggest of the terrestrial planets, and that gave it enough gravity so it could pull in and hold onto the hydrogen and the helium. So that's how the frost line caused the differentiation, the different parts of the solar system. Inside that all-important frost line, inside the frost line, you have your 4 terrestrial planets. Outside the frost line, you have your gas giants. And it's suspected that the frost line had a whole lot to do with how that all worked. Now, how did we end up getting water to the interior of the solar system? That's a current scientific mystery. It may have been comets and asteroids. We don't have a lot of data points on this yet. We are gathering more data points. Some of the data points says, yeah, these things have a fair bit of water. Some of them say they don't seem to have the water. So stay tuned. This is one of those astronomical mysteries that we should have enough data points to start saying meaningful things on before too long. Hey, thanks for watching.